Determine an equation of the inverse of y equals negative x squared. So when finding an inverse algebraically, the first thing we're always going to do, because this is what happens with an inverse, is we're going to switch x and y. Sometimes this simple step is worth a full mark on a question on the exam. One of the easiest full marks you can get, recognizing that with an inverse, that's switching x and y. Switch your x and y, and then solve for y. So after you've switched your x and y, the next thing you're going to do is solve for y. So I'm going to move the 4 over to the other side. Multiply everything by a negative to get the y squared by itself. We get the thing that's squared by itself, so we can get rid of the squared by square rooting. Remember that plus or minus out in front. So we get y equals plus or minus the square root of negative x plus 4. And now we get to a little bit of tricky part, sketching the graphs of both of them. Now it's tricky depending on how we go about solving it. So I'm going to start my graph here. I am going to graph my original function in green. So I'm going to put a green box around y equals negative x squared plus 4. This graph you should be able to visualize in your head using your transformations. What is going to happen? I'm going to have a parabola. The negative is going to be a vertical reflection, making it go down. And the plus 4 is going to shift it up 4. So when I go to graph it, parabola flip down, then shift it up 4. I'm going to have 0, 4 as my vertex, over 1, down 1, over 1, down 3. There's my original function. And in purple, I'm going to graph this. Now this is harder to graph from the equation, but if we know that an inverse is just switching x and y, if I label some of these points on my original graph, 1, 3, negative 1, 3, 2, 0, negative 2, 0, and I switch the x and the y's, well, 0, 4 is going to become 4, 0. 1, 3 is going to become 3, 1. Negative 1, 3 is going to become 3, negative 1. And 2, 0 becomes 0, 2. Negative 2, 0 becomes 0, negative 2. And that's the graph of the inverse. Could you have graphed the inverse using the equation? Yes. But with that plus or minus actually becomes two equations. One equation would be with the plus sign, negative x plus 4, and the other equation would be with the negative sign, with negative x plus 4. And we could graph these with transformations as well. What does the negative do? It's a reflection, horizontal or vertical reflection. It'll be a horizontal reflection, right? What about the plus 4? 4 up, 4 down, 4 left, 4 right. Okay. And this is why we have to set our phone to remind us at 10 o'clock that we always have to, when we have a horizontal stretch, compression, reflection, and a horizontal translation, it has to be written in factored form. And I think this is the hardest one to see that you have to write it in factored form. It will not go 4 to the left because you would first have to factor out that negative, making it x minus 4, shifting it 4 to the right. So you start with your square root graph. We have a horizontal reflection, making it go this way. And then you're going to need to move it 4 to the right. Can you see that that matches up with the top part of that horizontal parabola? And in the second equation, if, again, I would have to factor out the negative. The negative outside, we start with our regular square root. The negative outside would be a vertical reflection. The negative inside would be a horizontal reflection. And then it gets moved 4 to the right. Can you see that that matches up with the bottom part of the parabola? You see how much work the transformations were to get those graphs? How much easier it is if you have one of them. You can always graph the inverse by just switching the x and the y. By taking the points that I had on the green graph and just switching my coordinates, graphing my purple graph was so much easier. Plus, right, when I did a survey of you guys which way that +4 would go, we almost all made the mistake saying 4 to the left, forgetting that factored note, because that negative is so tiny out in front. So easy to make that mistake. So, part C, now that we've got our graphs, is the inverse a function? Is the purple graph a function? Does the purple graph pass the vertical line test? No. The purple graph does not pass the vertical line test, so the purple graph is not a function. Did you know there's something called the horizontal line test? Does it make sense that if the original function doesn't pass the horizontal line test, the inverse function won't pass the vertical line test? So I could tell just by looking at the parabola that the inverse won't be a function. Now, a parabola is x squared. And you know what's the opposite of squaring? Square rooting. Okay? But when we look at, right, when you look at your x squared graph, and you look at your square root graph, your square root graph, in order to be a function, they only take this part of the graph and flip it. They only take part where it would still pass the horizontal line test, so that your inverse function is still a function. If we drew the other half, it would be a sideways parabola, but then it wouldn't be a function anymore. And we want our calculator to calculate square roots, and so it needs to always be able to give us only one answer. And that's why the function of the square root is only part of that. Okay, questions to do are 7, 8, and I put a little star in my note that 11 and 13 are a little bit challenging. Oh, sorry, wrong questions. That's for later. Questions are just 5 and 6 for now. These are later. Sorry. Got all excited about trying 11 and 13.